Welcome back to your favorite Fundamentals College Math class. We're going to take a look today at measurement and dimensional analysis. We're going to start out with length, right, which is just your distance from one end to another. And then here's some conversion factors. So we'll use dimensional analysis or factor label method to convert between measurement units. All right, so you got 1 foot is 12 inches, 3 feet in a yard, 80 feet in a mile, and so on. So let's go ahead and do this first example. How many inches are in 3.5 feet? So 3.5 or 3.5 feet. I'm going to go ahead and write that. And now I know there's 12 inches for every 1 foot, or for every 1 foot there's 12 inches. So what I'm going to do is I'm trying to get these feet into inches. So I want my feet to cancel. And if you remember, like if you have like 7 over 7, right, that simplifies, cancels to 1. 1 over 1, right? We're just doing it with units. So I'm going to pick, which one of these two am I going to pick? I'm going to pick the one where it has my feet on the bottom. So I'm going to pick that first one. So I'm going to multiply it by 12 inches per 1 foot, because I know that's an equivalent statement, right? There's 12 inches for every foot. So it's kind of like I'm multiplying this by 7 over 7. I'm just multiplying it by 1. I'm not changing the 3.5 feet. I'm just converting the feet to inches. And now notice my feet over feet. See how my feet cancel? And so now I'm in inches. So now I just take out my calculator and I take 3.5 times 12 is 42 all over 1 times 1, and I'm in inches. So I have 3.5 feet is 42 inches. You're probably looking at that thinking, well, why do you need to do it that way? Well, if you get some things complicated, like let's say you're going from miles per hour to feet per second, and you're doing a bunch of conversions, that's when this dimensional analysis comes into play. So scientists and engineers really like this approach, dimensional analysis. So let's do another one. Interior decorator needs border trim for home. She needs 15 feet of border trim for the living room, 30 feet border trim for the bedroom, 26 feet for the dining room. How many yards trim does she need? So number one, well, first of all, how many total feet do we have here that we need trim? 15 feet, 30 feet, 26 feet. So it looks like I have 45 plus 26. So we got 71 feet. But how many yards is this, right? The question is, how many yards of border trim does she need? So we want to go from feet to yards. Well, we know there's 3 feet for every 1 yard. For every yard, there's 3 feet, right? So right now we have 71 feet. You can put that over 1. And we want the feet to cancel. So I'm going to pick the second one because I have feet on the bottom there. So I'm going to multiply for every 1 yard, there's 3 feet. Notice my feet cancel. So we got 71 times 1 is 71. 1 times 3 is 3. And I'm in yards. All right, so we have 71 over 3, which is 23.6 repeated yards. So here we're putting artificial turf in, and we got the dimensions, right, of a football field. Let's go ahead and draw this football field. Step 1, we got this football field, 120 yards by 50 yards wide, right? But the turf comes in square footage, right? So how many square feet is needed? Well, we could do square yards, but we need it in square feet. So let's go ahead and convert these yards to feet. So let's do the 120 yards first. Let's convert that to feet. We know there's 3 feet, so times it by 3 feet for every 1 yard. So we got 360 feet is my length. So I'm going to cross this out, and I'm going to say that's 360 feet, right? And then let's do the 50 yards as well. Let's convert that one to feet. 3 feet for every 1 yard. Notice my yards cancel. I get 50 times 3 is 150 feet. So let me cross that out. That's 150 feet. So it looks like here's our dimensions, 360 by 150. So the total square footage, right, the area that we got to put turf on this is 360 feet times 150 feet. So our square footage, that'd be 54,000 square feet. So that's how many square feet we need of turf. All right, let's go ahead and do, you guys go ahead and try this one. Use dimensional analysis to determine the number of feet in 2.5 miles. And remember, there's 5,280 feet in a mile. 5,280 feet in a mile. Well, if you got 2.5 miles, let me write that as an improper fraction. 2 times 2 plus 1 is 5 all over 2. So I have 5 halves miles. And I know there's 5,280 feet in a mile. And I want to use the first one because I want my miles to cancel. So now we're in feet. So I got 5 times 5,280. So I got 26,400 over 2 feet. In other words, 13,200 feet. So thanks for pausing that and working that problem. Let's move into weight. So weight, how heavy or light a person is. I don't like to talk about that at my age. Just kidding. But let's get into some weights here. And so let's start with 2 1/4 pounds. We know for every pound there's 16 ounces. So let's take that 2 1/4 pounds. And I'll write that as 2 times 4, 8 plus 1, 9/4. So that's 9/4 pounds, LBS pounds. And I know there's 16 ounces for every 1 pound. 1 pound, 16 ounces. So which one am I going to use? Well, I want the pounds to be on the bottom. So I'm going to use that first one. So times 16 ounces per pound. See how my pounds cancel? Now I'm in ounces. So I'm going to go 9 times 16. I get 144. 4 times 1 is 4, and I'm in ounces. So it looks like this ends up being 36 ounces. Let's look at another one. A municipal trash facility allows a person to throw away a max of 30 pounds of trash per week. Last week, 140 people threw away the maximum allowable trash. How many tons of trash does this equal? Well, for every ton, it's 2,000 pounds. So I'm going to make a note of that. There's 2,000 pounds for every ton. Okay. But number one, how much total trash do we have? How many total trash? Well, we have 30 pounds, and there's 140 people that are throwing stuff away, right? So if 140 people throw away the maximum amount, it looks like we would have 4,200 pounds thrown away, right? So now we just got to convert that. How many tons of trash is that? Well, we have 4,200 pounds being thrown away, and there's 1 ton for every 2,000 pounds. Notice our pounds cancel. So 4,200 times 1, 4,200, 1 times 2,000, 2,000. We're in tons. And 4,200 divided by 2,000 is 2.1 tons. 2.1 tons of trash. Let's look at this one more example, and then we'll have you guys try one. Post office charged 44 cents to mail something that weighs an ounce. Charge for each additional ounce is 17 cents. So how much will it cost to mail a package that weighs 2 pounds and 3 ounces? Well, let's go ahead and see how many total ounces that is first. So number one, what's our total ounces? Well, we have 2 pounds and 3 ounces. The ounces is fine, the 3 ounces is fine, but we got to convert the 2 pounds into ounces, right? So we got 2 pounds, got to convert that. So there's 16 ounces per pound. See my pounds cancel. So it looks like that's 32 ounces. Don't forget we still have an additional 3 ounces on this. So we have 32 ounces, that's the 2 pounds, plus 3 ounces. So it looks like we have a total of 35 ounces. So step 2, what would our cost be? Well, for the first ounce, it's 44 cents. Oops. 44 cents for that first ounce, right? Well, we have 35 ounces. So the other 34 ounces, it just costs 17 cents for the other 34 ounces. That's an ounce right there. And so it looks like I got 44 cents. I go ahead and punch in 0.17 times 34. That gives us $5.78. So it looks like total would be $6.22 to mail that package. And then go ahead and pause the video for example 4 there and go ahead and try that. Well, bluefin tuna is 1,800 pounds. A great white's 2.5 tons. So 2.5 tons. We're trying to figure out how many pounds that is. We know there's 2,000 pounds for every 1 ton. So 2.5. This is the great white. So the great white weighs 5,000 pounds. Now the bluefin tuna, on average, is 1,800 pounds. So what's the difference? Well, let's subtract the 2. And it looks like it's a difference of 3,200 pounds in weight between the great white and an average bluefin tuna. Capacity, so like the amount of liquid an object can hold when it's full, right? So like with milk, we're usually buying gallons of milk, right? That's capacity. And here's our unit equivalents, right? For every pint, there's 2 cups. For every quart, there's 2 pints, and so on. Let's go ahead and use this dimensional analysis to determine the number of pints in 2 3/4 gallons. So I have 2 3/4. So 4 times 2, 8 plus 3, 11/4 gallons. And I want it in pints. Well, I know there's 4 quarts in a gallon. So I'm going to 4 quarts per gallon. See how my gallons, so now I'm in quarts, right? So I'd have 11 quarts. But we don't want it in quarts, we want it in pints. I know there's 2 pints for every quart. 2 pints for every quart. So 2 pints for every 1 quart. I need the quart on the bottom. All right, so make sure you do 2 pints over 1 quart, not 1 quart over 2 pints. And now notice we're in pints, right? All my units have canceled. So let's go ahead and multiply all the numerators. 11 times 4 times 2. I've got 88 over 4 times 1 times 1. I got 4. So it looks like we have 22 pints. And that's 2 3/4 gallons is 22 pints. All right. Now you guys go ahead and try this one. Tasha's making some lemonade. Bring to the beach. She's got 2 containers. One holds a gallon, the other holds 2 quarts. If she fills both, how many cups will she have? So you want to put this into cups, all right? So take your gallons. Remember, there's 16 cups for every gallon. For every gallon, there's 16 cups, right? And then take the quarts and put that into cups. There's 4 quart cups for every quart. Well, if you're checking yourself, you take the first 1 gallon. We're going to convert that to cups. There's 16 cups for every gallon. So we got 16 cups for that one. The second container is 2 quarts. And there's 4 cups per quart. So it looks like this will be 8 cups. So how many total cups of lemonade can we hold? 24 cups between the two containers. All right, how about this one? Alan's making chili. He's using a recipe that makes 24 cups. He's got a 5-quart pot and a 2-gallon pot. So which one or both will fit the chili? Which one or both will fit the chili? So we want this in cups, don't we? So that we can compare this. Because we got to make 24 cups of chili. So let's look at this 5-quart pot. 5-quart pot. So we've got 5 quarts. And we know there's 4 cups for every quart. So it looks like this is 20 cups. Now remember, we're trying to make 24 cups of chili. So is it going to fit in there? No, yeah. No, will not fit in this container. So how about the, what's the other one? 2-gallon? We got a 2-gallon pot. So we got 2 gallons. And we know there's 16 cups per gallon. So it looks like this will hold 32 cups. So yeah, it looks like it'll fit in there. The 24 cups of chili we're going to make will fit in the 2-gallon container. So what's our answer? Not A, because it'll fit it just into, looks like D. All right, the chili will fit into the 2-gallon pot only. Well, that brings us to section 2.4, the metric system. We're one of only a couple countries that uses the U.S. customary measurement system. The metric system, frankly, is superior, you guys. And, of course, scientists and engineers will oftentimes use metric system, right? Because it's all base 10, right? You don't have this weird little, oh, there's 12 inches in a foot and 5,280 feet in a mile, right? Like it's all base 10. It's like, 100 centimeters in a meter and so on, right? It's all base 10. 1,000 meters in a kilometer and so on. So very easy to work with it mathematically. So we like that. The meter, the gram, and the liter are like your base units. And so, handle of a shovel is about a meter, paper clips about a gram, medium-sized container milk's about a liter, just for reference, right? And here's kind of how it rolls. They have these prefixes. And I have this kind of listed a couple different ways, including down here the whole prefix here. So, like for example, if you're using meters as our base unit, meter. You know what? Let me do that in. Okay, so length here. So a kilometer, 1 kilometer, that's times 1,000. So it takes 1,000 meters for a kilometer. A hectometer would be 100 meters make a hectometer. Meter M, right? 100 meters. A decameter would be 10. 1 decameter would be 10 meters. 1 decimeter. So it takes 10 of those. So it's a tenth of a meter. See the 0.1? So 10 decimeters, equals 1 meter. Centi means 1/100th. So it takes 100 centimeters to be 1 meter, and so on. All right. So that's how those prefixes work. This is just another way to say it. I just did it with grams instead of meters as your base, right? So you'll use meters or grams or liters for volume, right? That'll be your base unit and the prefixes. So here's some common ones that I've listed, and of course it just goes back to that table. But let's go ahead and convert 7,225 centimeters to meters. Again, we know that for every meter, there's 100 centimeters, or 100 centimeters for every 1 meter, right? Centi 1/100th. So let's see what we have to start with. We have 7,225 meters. Oh, centimeters, I'm sorry. Centimeters. Now we're trying to get rid of centimeters. We're trying to convert to meters. So we want to have centimeters on the bottom. So I'm going to pick that first one. For every 1 meter, there's 100 centimeters. Centimeters cancel. So it looks like I got 7,225 times 1 over 1 times 100. Now I'm in meters. So we get 72.25 meters once we divide that. Let's do another one here. In Summer Olympic Games, athletes compete in 100-meter dash or 200-meter dash. Here's all those races, all right? If a runner ran all of them, crazy enough, right? Someone runs all of them. How many kilometers would it be? Well, let's find out how much total meters it is first. How many total meters is this, since these are all in meters? You're running the 100-meter dash, a 200-meter dash, a 400, the 800. You're going to run the 1,500. You're going to run 5,000. And you're going to run the 10,000. Maybe you do it all in a day. Haha, just kidding. Well, that'd be 18,000 meters. Crazy, right? 18,000 meters you ran. How many kilometers is this? So step 2, we have 18,000 meters. Kilometer, so that's 1,000, kilo, 1,000. So there's, for every 1 kilometer, there's 1,000 meters. All right, meters cancel. So we got 18,000 times 1 over 1 times 1,000. And kilometers. So sure enough, 18 kilometers. All right, this next one we got a deciliter. Looks like we got a bottle with a deciliter, 295. It holds 295 deciliters. And then another bottle holds 28,000 milliliters. What's the difference in capacity? Well, let's go back to our base unit. Let's go to liters, and then we'll compare them in liters. All right. So number 1. We got 295 deciliters, and we know deci is 1/10, and so for every liter, I have 10 deciliters. So 295 times 1, 295, 1 times 10, 10. Now we're in liters. So we got 20. Okay, so this is a 29.5 capacity in liters, all right? Let's do the second bottle. Looks like we have 28,000 milliliters. So that's 1/1000th. In other words, for every 1 liter, there's 1,000 milliliters. It takes 1,000 milliliters for every liter. Equivalency, all right? So we got 28,000 divided by 1,000. Now we're in liters. So this is 28 liters. So what's our difference? Well, difference means subtract, right? Looks like that one is 29.5, the other one's 28. Looks like it's a difference of 1.5 liters. That one is a little bit bigger, 1.5 liters. Yeah, and this next one's a U-Triad problem. So go ahead and pause the video. Find if the distance from Scottsdale to Las Vegas is 421 kilometers. What is that in meters? And then find out what that is in centimeters. Well, for part A, we got 421 kilometers. We know there's 1,000 meters for every 1 kilometer. So this just ends up being 421,000 meters. And now we want that in centimeters. So we'll take the 421,000 meters. And we know there's 100 centimeters for every 1 meter. So 421,000 times 100, 42,100,000 centimeters. And thanks so much for watching. We'll see you guys next time.